Hello. In this problem, we want to evaluate the following logarithms exactly. In other words, without using a calculator. Now, A is log of 100, B is log base 3 of 81, and C is log base 2 of 1 over 64. Now, there is no base written here, which means we understand it to be 10. Ask yourself, 10 to what power gives you 100? If you said 2, that's correct. That's how you can evaluate these logarithms. Now, the other one, well, B actually is pretty much the same way. 3 to what power gives you 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81, which means 3 times 3 times 3 times 3, which is 3 to the fourth power. So this is 4. C, however, is a little bit more difficult. Actually, one second. That looks a little bit like 9, and I don't want that to look like 9. There we go. C is a little bit different because it says log base 2 of 1 over 64. Now, because this is a regular integer and this is a fraction, that means that I'm going to have a negative for my answer. And so ignore the fraction now, just look at the denominator. 2 to what power gives you 64? Well, if you said 6, you're correct. And so there you go. That's how you can tell how to do these. Now, to check your answer, or to do this another way, let's look at A here. I can actually say log base 10 of 100 is equal to some power of, or is equal to x, which means I can convert this into an exponential. That gives me 10 to the x power is equal to 100. Common base of 10 means 10 to the x power is equal to 10 squared, which means x equals 2. And so that's another way of getting 2. Also, I can say log base 3 of 81 is equal to x, which means 3 to the x power is equal to 81. Which means 3 to the x is equal to 3 to the fourth power, because 3 to the fourth power is 81. And again, that's why x is equal to 4, which is what I got originally over here. I can also do this with the last one, log base 2 of 1 over 64 is equal to x. So that means 2 to the x power is equal to 1 over 64. But this is a fraction and I don't like that. So I can make this 2 to the x power is equal to 64 to the negative 1. And that's why I knew originally that there would have to be a negative there. Now, 2 and 64 share a common base of 2. So this is 2 to the x is equal to parentheses 2 to the sixth power to the negative 1. And remember, an exponent to an exponent you multiply. That means 2 to the x is equal to 2 to the negative 6 power. And that's why x would equal negative 6. And that's why I can get negative 6 there as well. Now, to check yourself even further, you can go to your calculator. Now, it says don't use a calculator, and I don't want you to just randomly type it in and then give me the answer. I want you to use your calculator to check your answer. Now, on most calculators now, there is log base on there. So let's look at A here, log base 10 of 100. But that's just log 100. Click enter, and that tells me 2. Good. B is log base 3 of 81. Now, I can actually type in log 81 divided by log 3. And the reason why I can do that is because of the change of base theorem. So log of the argument divided by log of the base. Or I could have done natural log of the argument divided by natural log of the base. And this can be done on any calculator that you have. This calculator, however, has the built-in function of log base. If you click math and then go up 2 places, you should see log base. So this is log base 3, go right 1, of 81. and then you just click enter and it tells you what it is. It's 4. The same thing for C. If I wanted to do the change of base, it would be log 1 over 64, close parentheses, divided by log 2, close parentheses, click enter. Or I can do math, go up to, click enter, and I can just literally type in log base 2 of 1 over 64. Oops. Enter. And again, that's just -6.